Now, let's talk about the agent API, which we can use to build headless agents on the Agentforce platform. So, what are headless agents? Well, just like conversation-based agents, headless agents are also service agents. The only difference is instead of user interacting with them directly through a chat, we invoke them programmatically using the agent API. You can think of it like this. Any third-party application, maybe a Node.js application, a Java backend, or even another Salesforce org can call this agent API, trigger the agent, and receive a response back. Now you might ask, what real use cases does this solve? So let's take a simple practical example. Imagine a customer is on your travel website booking a holiday package. While the customer is checking out, you might want to offer additional recommendation like add-on activities, hotel upgrades, or special discounts based on their buying habits. Here, a headless agent can be triggered from the backend. It analyzes the customer's current selection, maybe look up offers stored in data cloud, and generate smart suggestions. The response comes back to your application, and then you can show these recommendations to the customer without them directly interacting with the agent. So the key point is, headless agents run silently in the background. They do not chat with the user directly, but their responses powers your application to deliver personalized experience. And thanks to this agent API, any app, no matter which platform it is built on, can invoke these agents just like calling any other Salesforce API and use the response in real time. So with these headless agents, we open up a lot of powerful automations and personalization possibilities beyond just a chat window. I think it will be easy to understand this concept through an example. So here I have built a simple book library application. Ideally, this should have been a Node.js website, but just to keep things simple and focus on the concept, I have built it as an LWC component inside a Salesforce org. In this application, user can search for the books in the library, mark books as favorite, and save them for easy access later. But here is an important point. This library does not contain all the books that the company actually offers. So here, if I show you, this has only 30 to 40 books of this company, but the complete list of book is stored in a master Salesforce org. So here I have another Salesforce org, which you can think of it as a master org, and this was like a subsidiary org of this Salesforce org. And here we have all the master book list. So here I have this PDF document, which is containing all the books that this company is offering, and this PDF is uploaded into data cloud because this master org has access to data cloud. So all of these unstructured data, ledger data, all of that is stored in the data cloud, and since they have access to data cloud, they can access all of these unstructured data. And similarly, in this master org, we also have built this agent, which is library agent. The job of this agent is simple: recommend books based on the user's current books, preferred genre, or languages. Now here is an important point. This agent currently lives in the master org, but our book library, which is in this org, is running in another Salesforce org, or maybe even on a third-party platform. So how do we make this agent work for our book library app? So this is exactly where the agent API comes in. When a user is browsing books in our app and shows interest in a particular genre or language, our application can call the agent API, invoke the recommendation agent, which is basically the library agent which is currently hosted on the other Salesforce org, and get back personalized book suggestion. These suggestions can then directly be displayed to the user without them even knowing that the logic is running in the another org. And here this agent is running in the backend. The agent is in the other org, and this org is making a call out to that agent asking that this user has currently, marked this book as a, favorite book, because using this favorite icon, I can mark this book as a favorite. So this book title, this genre, and this language can be passed to this agent, the recommendation agent, and it will then look into this master book list and find all the relevant or recommended books that can be shown to this user. And that's how in the real time from this org we will access this agent, which will access company data which is residing in the Salesforce objects, or maybe in the unstructured data, and generate a appropriate response, send it back to this application, and then this application can use that data to personalize the user response. So let's just do that. But before that, if I show you this component, it's a very simple component. It is showing showing all the books that this org currently have. And if a user want to search, they can search the books here like this, and all of the books with that name will come up here, and then they can get all the information about the book title. This is a Dracula book, the genre is horror, and language is this, and the price is this. And then if they mark any of these book as favorite, that is where we want to trigger our headless agent, which is basically the agent in the other org, passing the book title, passing the book genre, passing the book language. And we want our library agent to look into all of the data sources, whether it is in the Salesforce objects or in the data cloud, in the PDF, or in any other form, and recommend us books that we can show to this user. So for example, I'm going to mark Dune as a favorite book. That I can do by using this star icon here. And when I click on this, what is going to happen is the customer is not aware, but in the backend we have just invoked the headless agent, the agent in the other org, and now you see a recommendation come here. So here it is saying that here are some recommended books similar to Dune in the science fiction. So if you see, where is that Dune book gone? Yeah, here it is. So we marked Dune as our favorite book, and it was science fiction. The language was English. So what we got the response as, here are some recommended books similar to Dune in the science fiction genre and English language, Galactic Wars. Now this Galactic Wars is actually not a book in this org. So this org has very limited stock right now, because this company does not send all of the books. If people are not interested, they won't send it, but rather this is there in the master list. So if you see here, this was a science fiction. So here, if I go to this master list, we see that Galactic Wars, which is the genre is science fiction and language is English, this book is being recommended here. Similarly, it is also showing this Cyber Mind. Again, this book, these books are not here in this org. So if I search for it, these books are not here, but it is there in the master book list. So if I search here, yeah, here it is. Again, it is science fiction, the language is English. That's why this book is being recommended by our agent. And then I think it has recommended one more book, which is Lost Colony, because that's how I have trained the agent, that you have to, show 2 or 3 book only. I mean, it can actually find more books, but for this example, I just trained the agent to, send 2 to 3 books only. So again here, if you see Lost Colony, again science fiction, language is English, and price is $18. That's been shown here. Now what could happen next is, you may have some buttons here where this customer can show interest into Galactic Wars, and that is where the librarian of this org can raise a request to the master org saying that, deliver this book to this library, and that's how that book will be available in this org. Similarly, let's say that maybe this one, it's a thriller book, Gone Girl. Let me mark this as favorite. Maybe I can close this, and I'm going to mark Gone Girl as my favorite. Again, same thing is happening. The agent is going to be invoked, passing the current book that the user has selected, the current genre and the current language. And again, here are some recommended books similar to Gone Girl in the thriller suspense genre and English language, The Silent Lake. Again, these books are coming from the master book list, because in this org I have a data library. In that I have uploaded this PDF document, and through that our agent has access to this master list, so it can actually look for these books, passing the genre and the language, and that's what it is displaying to this user. So here you see that this user is not directly interacting with the agent. So generally you will have your agents like this. It's not like that. This user is just working, this user is just going through the website, clicking here and there, and that is where you are invoking your agents in the backend. The agents are working. It is very similar to, I'm asking this agent here, can you recommend me some books which are very similar to, let's say, The Hobbit. So I'm not asking that, I'm not initiating a conversation with the agent, but it is doing the same thing, and that is where it's a headless agent. Nobody is invoking it, rather it is being invoked based on clicks and based on different activity that the user is performing on the website. So I hope you understood this use cases. Again, it's a very simple use case. This can be actually be very powerful because your agents are working in the back end. You can invoke one agent in one org, or you can orchestrate it. Multiple agents can work together and respond back, and you can use that response for better responses. So let's learn about this agent API and how to build these kind of solutions. So in next few lectures, we are going to work with few components, few Apex classes, LWC and objects. So all of that I have added in this GitHub repo. You can refer the component from this GitHub repo, or if you want to deploy that to your org, that also you can do that. So let me just do that. So I'm going to deploy this to a brand new org, and here I can open terminal. Again, the prerequisite are that you should have Git and Salesforce CLI installed. So I'm going to say git clone. It is git clone. And I see that the repo is cloned here, so I can go into that repo. So here you see in the Force app, we have the classes, the LWC component, the objects, profile permission, tabs, and also this books data load that I did. That CSV file is also available here. And let's just deploy this Force app to the new org. So for that, let's just authorize to the new org. New. Right, so I have authorized to the org. So let's go back here. And now I can deploy this component to the new org. So let me just click on deploy this source to org. Right, so I see that all of these components are deployed. Apex classes, lightning component, custom fields, custom object, and custom tab as well as profile is deployed. So let's go to the org here. This was the org where I have deployed it. And let's just see that. So I should have a book. Yeah, so books tab is available here and it will take some time. But yeah, this is that books tab. So I need to do the data load here. So let me quickly do that as well. So for that, I can use this one and I can copy everything, go back to the org. You can use this Salesforce inspector and can do a data import in the books one. And let me click on run insert. Right now the books are loaded. Let's just see that. Yeah, so 40 books are available here. And then we have this library tab where we have this LWC component added. Yeah. Okay, so basically, so this is failing because, in my metadata, I have not configured the client ID and secret. But overall, this LWC is loading all the book record here. So we are good to go and we can work on the authorization part of it. So you can follow along the lectures to see all of this. In this lecture, let's start working in the master org. So we basically want to set up our agent, which we are going to invoke in the other Salesforce org. So for this example, this is the master list PDF that I want to upload into the data cloud, as you saw in the last lecture. From here only, our agent is going to find the recommended book titles. I have already uploaded this PDF document into one of the Agentforce data library called master book list, and we had discussed this in our previous lectures on Agentforce data library, that the moment we do that, what actually happens is this content goes to the data cloud in the data stream. From there it goes to the data lake object, from there into the data model object. Then we have the retriever created, which uses the search index query in this unstructured data. So all of that has already happened because I had uploaded this like long back, and because of that the retriever is actually ready. So if I go to the Einstein Studio, I have this file master book list retriever, which is available here, and using this we can get content from this master book list. So I'm going to upload this master book list PDF in the resource section. You also just create a new Agentforce data library in your org and upload this PDF document and wait for some times before testing it out. And I've already tested it and it is working fine. So we are done with the data cloud part of it. Now the next step is we need to create our agents. So let's go to the agent builder or Agentforce Studio and let's create a new agent. And we are going to create a service agent. So let's create an Agentforce service agent here. And I don't need any of these topic. We'll just create our own topic. Let's click on next, and I'm going to call it headless agent, maybe. This agent will find the book recommendation. And I'm going to use my existing agent only, which I can use this one, and let's click on next. So here for this agent, we can give it access to the data library, or optionally, we can actually build a prompt template which will utilize the retriever to get the information from the data library. I would go with the second approach. The reason here is that I need to give more and more instructions for it to generate the final response. Doing that in the topics instruction is little heck. So I'm going to use the prompt template, because there we can give the instruction, we can test with different models, whichever model is giving the best response, we can use that. So I'm not going to choose the data library here, but this agent will have access to the data library through the prompt template. So let's just create it right now. So this is our agent. Let's create a new topic here, and we can say that it will be a topic for book recommendation. I'm going to change this with my already created topic. And these instructions I can remove. And I can say that the user will share the book name, genre, and language which they like. Your job is to find the similar books titles that you can share with the user. So with that, the action is not yet available. We need to create this action. First of all, we need to create the prompt template, which we will use as the custom action. Again, the reason here is that you can actually go with the data library directly, and this agent, you can give instruction to the agent that this is how your final response will be. I would go with the prompt template because that gives me more flexibility to work with the data library or the retriever. So for now, let me just finish it here. So yeah, we have a topic here, and let's go to prompt builder. I'm going to quickly create a prompt template. So this will be of type knowledge answer, because we want to work with the retriever. So we need to choose the prompt template type as knowledge answer, and here we can call it books finder maybe. And to this, I'm going to give instruction which I have already have written it. So I'm just going to copy paste it here, and let's just read it together. So I'm just saying that analyze the query, carefully read and understand the user's question or request from the question section in the input. In the input, you will get a book name with its genre and language. You need to find the similar books from the knowledge. So we are going to give it access to the knowledge through the data retriever. From there, it needs to find the similar books. Based on the book genre and language, find around 2 or 3 similar books with the same genre and language. So here you can change these instructions. You can train your own prompt. You can train your LLM model how you want your book recommendation to be. But to keep it simple, I'm just saying that just find 2 or 3 similar books with the same genre and language. So if the genre is horror and language is Russian, I want it to find out the very similar books. And if it finds like a lot of it, I just want to send 2 or 3, because we're just giving some suggestion right now. Return the final response containing the recommended book name hyphen genre and the language. For example, for a book Galactic War, send the response as Galactic Wars hyphen science fiction and English. So this is what I want to send back to the agent, and then agent will actually prepare a proper list of these recommendations that will be sent back to the caller. Find most suitable 2 or 3 books. Again, I'm saying the same thing, like you need to find 2 or 3 books and send it back as a response. Identify the article chunk most relevant to the user query. Final touches, make sure the response is clear, professional and polite. Language, English only. Output only the book's detail in given format at step 4. So in the step 4, we mentioned that what is the format that we are looking for. So after that, we need to give it access to the data retriever. So for that, we can say that the knowledge here will be from the resource section. We can go to the Einstein search and we can go to the rag file UDMO, and ours is this file master book list. So you remember, this is the master book list. From there we got the file master book list. This is the retriever that we need to use. And now here, if I click on this, it will ask that what is the input. So that will be free text and the user query. And after that, we can give question and the response. So this is my simple prompt template that I'm going to use as my custom action. Again, why I'm going with the prompt template route instead of data library directly to the agent forces, because I can give more instructions here. I can test my inputs. I can test with different models. Whichever model suits well, I can choose with that one. So it gives me more flexibility when working with the data clouds, unstructured data. So with this, let's just test it out. So I'm going to give it a query here, find recommended books similar to Dracula, language English and genre horror. So this is my data retriever. So it is giving me Midnight Shadow horror English and Vampire Promise horror English. So it's giving me 2 books recommendation, which is fine. But if you think that you have more than that many books, it should have actually given 3 books. Then what you can do is you can tweak your model here. Instead of using GPT-4 Omni, you can give more instructions as well. But I think for this example, this is fine. So I can just activate this prompt template. Now with this prompt template, we can create a custom action here for this topic. So here, let's create a new action. So we are going to use the prompt template, and here we can use the book finder prompt template that we just created. Let's click on next. Here I can say that the action find similar book title as shared by user, finding recommended books. So here in the query, it will be the user's query containing book name, genre and language which they like. And then because we have already hard coded the retriever ID or the retriever in the prompt template, I can just pass any random ID, because if you remember here, we have the this retriever directly added. We are not using the dynamic retriever, so we can just pass any random ID here, not important. And here in the response, this is what I want to show in the conversation. With that, I think we can click on finish. And now let's just test it out, that what is the response that we're getting from this agent. So I'm going to give the similar prompt here as well. Who's going to generate this prompt? This prompt will be generated by the calling application. They need to generate this prompt and send to this agent. This agent will then generate a response like this, and this is the response that we want to send back, which the calling application will decide how they want to use it. For example, in our use case, we were showing it as a recommendation on the top right side as a notification. So the calling application decide what they want to do with that response. So this is our agent which is currently generating this response, and to generate this response, it is using this prompt template. This prompt template is using this retriever, which is basically this PDF data. So all of this book list that we have, I mean, it's just 50 or 60 here, but if you have like multiple PDFs, all of that you can upload here, and then this prompt template will be able to find the recommended books from here. And then this agent which we just created, it will utilize this prompt template to generate the response. And this is currently, a conversation agent. We need to invoke this agent from the other application, from a third-party application running on Node.js, Java, or other Salesforce org. So for that, we need to create connected apps, and we need to test whether this response is coming through the API or not. So let's just do that in the next lecture. For now, I can just activate this agent. So right now we have configured our agent, and through the UI we are able to invoke it, and if we pass it a prompt something like this, it is able to give us some recommended book. Now here you will see that it is just giving the book title, but genre and all it is not giving. In that case, you can go back to your prompt template and ask it that you always send back the book name, book title, genre, and the language as well. But that is fine, we can check that later as well. Now the main point is, this is a headless agent, which means that we are going to invoke it through the API. So which means that someone has to make call out into this org using the REST API. So for that, we need to create a connected app. And also, if you go to the connection tab, so this agent, usually we create omni-channel flows, right? Which defines how this agent is going to come onto the UI. But if you see here, we also have this connections option here. And this is what we are going to use now to make this available as a API agent, or make it available on the agent API. So agent API is something that we are going to use it. But for this agent to be available into that agent API, we need to create a connection here, which simply means that create a connected app, and through that connected app only this agent will be invoked. So if I click on this add button here, it will say that connection type is API, right? And it is saying that it needs a connected app. So let's just create that. So for that, you can click on this new connected app, and it should take you to the app manager. Recently Salesforce has stopped creating the connected app from here. You can create the external client app, but for this one I just want to create a connected app, and that you can do from the external. So if you go to the external client app settings, here you still have the option to create the connected app. So you see that you need to make this checkbox true. I have made that. I had already made that, allow creation of connected app. So if you make it true, from here you can still create the connected app. So I'm just going to create a new connected app, and we are going to say that headless agent app. I can give some contact email here, and we need to enable the auth setting. The callback URL, you can give anything because we are going to use the client credential flow. So I can say that https www.login.salesforce.com. That should be fine. And here in the auth scope, we need some of the auth scopes. Make sure that you're adding that. We need this chatbot API. This is needed. And then we also need this Salesforce API platform. This is also needed. And then we need this manage user data via API. And finally, we needed the refresh token. So these are the 4 scopes you should give in the connected app. And then you can actually remove all of this. What we need is we need this enable client credential flow. And we also need it, and we also need this issue JSON web token. So these are the two checkboxes you should check here, and that should be it. We can click on save. Now let's go to the manage. Since it's a client credential app, it should run as a user, right? So it should run as a user. That we need to define in the policies. And here we can say in the client credential flow, we can say that it will run as a user. So let me choose. Obviously you should choose an user which does not have lot of access. It should only have the API access. It's not a real user, but this is just a developer org, so I can use my user. But again, make sure that this is really important, because once you have the token, you can make a lot of changes to this org. So you make sure that you're giving a user with the bare minimum access, just the API access, nothing more than that. And with that, let's just click on save. So if we go back to app manager now, we need the client ID and client secret. So this is the one headless agent app that I just created. So click here and click on view, and click on manage consumer detail. So now it will send a OTP to my email address, which I need to get the client ID and client secret. So this is my verification code, and now I will get access to my client ID and secret. Make sure that you're storing it at a secure location. So let's just copy this. This would be needed, and this is my consumer secret, and I can close this. So this is the connected app that we have created, and I have actually taken the client ID and client secret. So the next step is we need to connect this headless agent app connected app to our agent. So that now we can do that. I can say that headless app, anything you can give here, and here you need to search for it, and here it is. Now it is coming up. So you have to create a connected app, and then you can connect that to your agent. And once you do that, and then you will see that in the connections we have this headless agent app, which is our connected app. Anyone who has the details of that connected app will be able to invoke this agent after getting the token. So that's it for this lecture. Let's meet in the next lecture where we are going to test this from the Postman. First of all, I mean, we have to create the Apex class in the other org to make call out to this org. But before that, we will test this in the Postman to see that if we are getting the response or not, and how to send the request to get this response from the agent. Now, before going to the other org and build the integration to invoke this agent using the agent API, let's just try it out in the Postman. So I have Postman installed in my system. You can just download it from Google, and once you have it installed, you can log in with your user. And to practice this agent API, Salesforce has actually added the entire collection into their Salesforce developer. So what you can do is, once you have your Postman open, in the search Postman, just search for Salesforce. So this is Salesforce developer, and if you open it here, you will see that all of the APIs are available here, like your normal data cloud API, your platform APIs, bulk API version 1, bulk API v2, REST APIs, all the APIs are available. And then recently they added the agent API, and this is the one that we are going to work with. So what you can do is just click on this agent API and then click on the fork. So it will create a local copy where you can make changes to it. So let me just click on that, and it will fork it, and we are going to say that Salesforce developers fork, and let me click on fork collection. So now this is a local copy of this agent API here, and here we have different endpoints. So the first one is the start session. So this agent API is bit different than the normal APIs that you have worked with. In the normal REST APIs, you make a call out to get the token, and once you have the token, you just make a call out to get the response. But here, the first thing that we need to do is get the token. So you can use different ways. So our connected app says that using the client credential. So using the client credential, we'll first get the token. Using that token, we need to first start a session. Now, why that is needed is, if you remember, when we have this conversation with our conversation agent, that entire session needs to be, the agent is aware of the session. So whatever the conversation you had like 2 minutes back, it is still aware of that. So that's the session that it maintains. Now here also, when you invoke this agent from third-party application, let's say that it was a Node.js application and you wanted to build a very conversation-based agent on that page as well. So there also you want to maintain that entire session, right? Because again, you're building a conversation, a chat bot on that Node.js application. So you want your Agentforce agent to remember everything that has happened on that chat session. So for that, we need to first start a session. It will give us the session ID, and then we can either use the send message synchronous or send message streaming. So these are the two different ways we can send our message, and we'll just check that. But before going there, let's just click on this agent API here, and we need to first get the token, right? So for that, we need to set up these variables here. Here you see that it is already populated SF API host with https api.salesforce.com. So this is where we will, so this is what we need to hit to get the session as well as to send the message. But in the SF org domain, we need to give our org domain from where we are going to authorize. So here I can give my org's URL. Make sure that you are giving that my.salesforce.com, not the lightning one, and then the client ID and client secret. So the client ID, client secret that we got from the connected app, I'm going to go and paste it here, and the client secret here, and then agent ID. So which agent do you want to invoke in the Postman collection is what we are saying, that in the Postman collection you are trying to say that this agent is what I want to invoke. So let's go back to our agent. So this is our agent, and here I have this agent ID. You can see it from here, or maybe if you go to your agent builder, and here in the Agentforce agent, here I have this headless agent, and here you see the copilot ID, so which is the same as this one. So this is the agent ID that I can copy from here, and here I can paste it in the agent ID. right? And session ID is something that will generate and get stored here, so that should be fine. Now come to the authorization and click on get new access token. So okay, I need to save it, my bad. And let's go to authorization now, and now click on net get new access token. So it is going to use these variables that we have defined, and it will get the access token, and just click on use token. So what happened here is that we have defined all this client ID and all. So Postman has actually used that to get the access token, and that access token is now stored. So the first thing is, let's see the start session. Now you remember that this is the agent ID. So we have already mentioned that which agent it is going to invoke. So the first thing is start session. And here you see that all the variables are populated. SF API host is currently having this URL, https api.salesforce.com. And in the agent ID, this is the agent ID that we have stored in the variable. So we are saying that we are going to hit this, and it is going to use the access token. So here it is, the access token is here in the authorization. So let me just click on send, and what we will see is that it is going to start a new session. So this is the session ID that it is giving. It's giving me other information as well, and by default the first message that comes here. So this is as good as let's just go here in our agent builder. So this is a new session that we are starting right now, and this is the message that it gives, right? So we have the new session generated right now. In this session, whatever the messages that I'm going to type, it is going to remember all of that, and it is same here as well. This is the session ID that it has generated, and it would have saved it as well. Now the next thing is, we need to invoke this agent with any message that we want to send. We have two type of messages, and before showing that, when we invoke this session API to get the session ID, in the body we passed few information, which is really important here. So we are passing the GUID, which is basically a random ID that you need to pass, and this is the body that we will also prepare when we are going to invoke this from the Apex. There also we will hit this endpoint, and we are going to send the same body. We are going to pass the access token. So first we will get the access token, we will hit this endpoint with the access token, and this is the body that we need to send. And here this GUID is nothing but random ID that you need to pass. Endpoint would be your SF org domain. So again, same thing, the org domain that I stored in the variable. These are optional parameter. This is time zone, so I'm saying that which is the time zone, and the variable. And feature support, I'm saying streaming. So which means that in this session I can either go with the synchronous approach or also streaming approach. So for both of that we have two different endpoints, and we will see that. And when in the streaming mode, how the data will come back, the chunk types will be text. So when it will generate the chunk, we will see that when we hit this streaming API, we will see that how it is generating the response in small chunks, and there the chunk type is text. So this is really important. We need to remember that this is the same JSON body that we also have to pass. So if we are a Node.js application, we need to hit this API. Before hitting this API, we need to have the access token. So that access token, for that you need to use this client ID and client secret to get the access token. Using that access token, we are going to hit this, and passing this JSON body, it will give us the session ID back. And this is the session ID that you need to store in your application's variable, because we are going to use it again and again. Every time you want to send a message, make sure that you're passing this session ID. And now let's just see this one, send message synchronous. So here you see that it is passing the same session ID. In this one, we are going to use the same one, https api.salesforce.com followed by Einstein/AI agent/v1 session. So now we are hitting this endpoint sessions, and we are passing the session ID, and we are saying that we are going to pass some messages. So where is that message? Let's go to the body, and here we can say that whatever the message that we want to pass, our message was, so this is the message that I want. Again, this is a timestamp. Again, in the Apex code we will generate this timestamp, and this message is what I'm sending to my agent. Again, which agent? This agent was mentioned here. This is our agent ID. To this agent ID we got this session ID, so we don't have to pass agent ID in these endpoints. Rather, we just need to pass the session ID, and in the body we need to pass the text message that we want to send. So let me just click on send. And this is where you will understand what is the difference between synchronous and streaming. In synchronous, it will invoke the agent. You remember, agent will take some time. It is going to invoke the prompt template. If it has to invoke multiple actions, it is definitely going to take more time. And here it took less time, actually 7 seconds. But you can understand that some actions, some prompt would require agent to take more time. in that case you might go with the streaming endpoint, because there you will get the chunks continuously, and we will see that when to go with the synchronous and streaming. So in the synchronous one, it will make the call out and it will wait for agent to respond, and the entire message will come back at a once. In case of streaming, it will come in a pieces of chunk. So here it waited for the agent to generate the entire message or the response, and then only it responded back with the status 200. And here you see that this is our message. So here are some recommended books similar to Dracula in the horror genre and English language. So this is what it is giving us, the recommendation, right? So this is the synchronous endpoint, and this is actually useful when we build headless agent, where user is not talking to the agent, so he's not waiting for the response. In our case, what will happen is user will say that this is my favorite book, and we will invoke the agent in the backend. So even if it takes 7 seconds or 10 seconds, user is not going to be worried at that moment. So synchronous endpoint is very much suitable for the headless agents, and streaming is suitable when you have like chatbot kind of thing that you're building on your external websites. Because here, let's just actually try it again. It has the same session ID, and in the body I'm going to give the same prompt. Nothing changes here. Only thing changes is after the messages we have the stream, and here if you see that it was only messages, and here it is saying that stream. And this is possible because while starting the session we said that we need the streaming as well. Okay, and with that I'm going to give the same response, and now you will see that what is the response we are going to get back. So you see that it corrected, and now we got the first response here, and you will see that so we got the first response, and we got multiple responses. It's not waiting for the entire 8 seconds, rather it started giving me the the responses in chunks. The first one was when we passed this prompt, it said that finding recommended books, and this is actually the message that we have given on the action level. You remember, right? Let's go back to our agent. So here to this action level we have given a show loading text message, right? Finding recommended books. So this is how Agentforce also does it. It shows this loading text first, and then it slowly starts showing up all the chunks. So that's exactly what is happening here in the Postman as well. The first thing that it gave us back is finding recommended books. So now this is your job as a vendor who's using these APIs to first get this response and show this on the UI, and then subsequently you will get the first part of chunk. So here it is saying that here are some recommended books similar to this. It did not give the entire response but some part of it. Now it is your job to show this, and then once you get the next chunk you concatenate that. So to the first response you will concatenate this response, and then you will concatenate this response, and then you will concatenate this response, and finally I think this is done. So here in this one, if I can drag it, in this one, the final one, in the inform you will get the entire message again. So this is as good as the synchronous one. So in this payload you will get the entire message. So I hope you understood what exactly is this streaming doing. Instead of waiting for the entire message, it is actually going to send us responses chunk by chunk, and then it is your responsibility as a vendor to get these messages and then display it on your chatbot however you want to show this first, and then you can show the half part of the message, or you want to wait for entire message to come. Maybe in that case you should directly go with the synchronous endpoint. And then finally, as a good developer, you should end the session as well. So which is as good as in here when we were chatting with this, when we end the conversation, you remember in the community side, that is same as this. You can click on this send and it will end the session. Okay, so these are the 4 endpoints which we have to work with. The first one is the start session, where we need to pass the agent ID. It will give us the session ID. That's the session ID that we will use either with this synchronous endpoint or this streaming endpoint. And finally, you can end the session as well. So I would recommend you to play around here in this Postman collection so that you get understanding of this. What is this endpoint that we are going to hit? What information we need to pass? To start the session, we need to pass the access token, and we need to pass this JSON payload. That will only give us the session ID. This session ID, we will store it somewhere, and then that is what we are going to use for sending our messages. So here, this is the session ID that we are passing here. Okay, it got expired because we killed the session, and then in the body we were passing the text message. we saw how to invoke this agent through the agent API in the Postman. And now we have to do the similar thing in our client org, which is our base org, from where we want to invoke the master org to get the recommendation whenever someone shows interest into one type of book. So for that, let's go to that org. So this is my child org, or I could say that vendor org, from where I'm going to make a call out to the master org, which has access to the data cloud and where our agent resides. Now, as we saw in the Postman, we basically have to invoke this endpoint to get the messages. Again, since we are going to build a headless agent, we don't want a real-time response that we can show to the client. So we can go with this particular endpoint, because here we will get the final response. That is what we need. So we are going to work with this particular endpoint. But if you are going to build a chat-like interface where once a user gives a prompt, you want to show the first part of the message and then keeps on increasing the message, then you can also go with the streaming API. So again, for this endpoint, we need the session ID, and for the session ID, we need to invoke this API to get the session ID by passing the agent ID. And here we knew that we need the token. So in the authorization, we were passing the access token. So to get the access token, we need to utilize these client ID, client secret, and we have to make a call out to the Salesforce get token service that will give us the token. And using that, we can first make a call out to get the session ID. And once we have the session ID, then we can make call out to this particular endpoint where we can pass the user message and it will give us the response back. So the first thing that we need to do is we need to store these information somewhere in our org as well. So what I'm going to do is I'll just take it away from this screen, and here you can store it anywhere, wherever you want to, like whatever your company is following for integration best practices. But for this example, I'm going to store it in a custom metadata. So here I have this creds metadata, and let me show you this. In this one, I have these custom fields. So first I have is agent ID. So this will tell us that you can have multiple records here in case you want to make call out to multiple agents in the parent org. So each record in the metadata will represent one of the agent on that org. So here we can store the agent ID. Here we can store the API endpoint, which is basically the API endpoint which we had here. So this is that API endpoint that we will store here. Okay. And let me show you other fields here. Then we have the client ID, client secret, org domain, and the token endpoint from where we can get the token. So all of these fields are here. Again, if you want to have more fields, you can have that as well. But I think these many fields are sufficient. And I actually have one record here. And let me just clone it to create a new record. So we can say that headless agent. We need to add the client ID here. So I'm going to copy it from my Postman collection. Then we need to store the client secret here. The token endpoint will remain this only. It could be login.salesforce.com /services/auth2.token. But if you have enabled my domain, then you can give the domain. It is again a standard endpoint to get the token. You can find it from any REST API documentation. And the API endpoint. So this is the API endpoint, api.salesforce.com. And again, I'm adding more placeholders here because Einstein AI agent /v1, I'm storing till this point here. And this will be my base endpoint. I will be adding endpoint for the session and for the messages. So again, if I show you here, when we were invoking this start session, then it was api.salesforce.com /Einstein/AI agent /v1. So up to this point, the URL is actually common. So this part I'm storing in the metadata, and this part is something that will vary. So here we were saying after v1 we have agents, we have to pass the agent ID and sessions. And when we have to invoke the message API, then again after v1 we will change the endpoint. So this part I'm storing in the metadata. Right. And the org domain, this is my org domain. This is needed. This is needed actually when we have to get the session token. So if I show you here, when we were getting the session token in the body, we were passing the endpoint, which is basically the org domain. So this org domain we were storing here. You see this one. This is the org domain. So we need to store this as well. So that is what we have here. And here we need to copy paste the agent ID. So let's get that agent ID from the master org. So this is my master org, and here let's go to our agent. So this is our headless agent, and this is the agent ID that we need. So I can copy and paste it here. So now we have this custom metadata setup here where I have my headless agent with all the information needed to get the token, to make a call out to the API endpoint, and the agent ID also stored in this metadata. So now we are going to use this in this org. So we are going to create a Apex class. So for that, let's create an Apex class. I'm going to open my cursor IDE. I use this because it really helps me write the code really fast. You know, building LWC component is just asking my agent. It helps me build this boilerplate LWC component. So I use cursor, and if you are using VS Code or IntelliJ IDE, that's fine. We just need to create an Apex class. So here I can say that create Apex class headless agent service. Right, so the first thing that I want to do in this one, I need to store this information, whatever we have in the metadata. So you see that it actually started giving me suggestions. So I need to store the client ID in this variable. I need to store the client secret, token endpoint, API endpoint, org domain, and agent ID here. That I can do in the constructor, or maybe we can use a static block as well. So I'm just going to have a static block here. So what I'm doing right now here is that I'm getting the metadata record. So in this case, I need to get the correct metadata record, which we just created right now, which is this one, headless agent. So I'll just update it here. So here you see what we are doing is we are getting the metadata record. From there, whatever the client ID we have stored in the metadata, that I'm storing here, client secret I'm storing here, token endpoint I'm storing here, API endpoint I'm storing here, org domain is here, and agent ID is here. Now the first thing that we need is we need to get the token. So again, if you see here, to invoke this start session, we needed the token. And to get the token, we need to hit the token API service from Salesforce, which is common when you want to invoke any REST API service in Salesforce. So for that, I have actually written the code. I'm just going to copy paste here, and let's just walk through that. So here we are saying that I have this method called get token. So the endpoint would be token endpoint. This token endpoint we have stored in the metadata, and the grant type will be client credential. If you remember, in the parent org, in the master org, we have created a connected app, and this client ID, client secret, is coming from that connected app, and there we have chosen client credential. The grant type we had chosen as client credential. So for client credential, we need to pass the client ID, and we also have to pass the client secret, and that's what our endpoint is. So this endpoint is what I'm going to access to get the access token. So I'm setting the endpoint here. The set method is get, and we are going to hit this, and it will give us the response body. It will be a JSON. In that JSON, we will have the access token, right? And that's the access token that I'm returning from here. So anyone who makes call out to this token method will get back the access token. But before that, make sure that this endpoint, API endpoint, token endpoint, everything is added in the remote site setting. So let's just quickly verify that as well. So let's go to the remote site setting, because we are going to make call out from here. So here you see that for the agent API, I have a remote site setting here, and for the org, like for getting the token, I'm going to hit this one where I'm going to get the token. So again, this URL is basically this one, token endpoint URL is this one. So this org /services/auth true/token. So I'm going to make a call out here. So I need to add that as a remote site setting. So I have added all that in this org. So we are actually good to go. And so as of now, what we have done is we created a new class, headless agent service, where we have these attributes which are going to store the information from the metadata, and that we are storing in this static block. And after that, we have created one method which is going to return a access token. So let's just deploy this. Let's see if we are able to deploy this. Yes, so this got deployed, and now what we can do is we can actually test it out. So here I can, just run some anonymous code. Again, you can go back to your developer console, and from anonymous block you can do that, and or else you can do it from cursor as well. And you see this is intelligent enough to understand that I'm going to write this code. So I'm saying that system.debug the token headless agent service get token. So I just want to invoke this method to see that if we are getting the access token or not. If we get the access token, it is going to return it, right? So we are just debugging it if we are getting that or not. So I can just select it and Control Shift P and execute anonymous apex with currently selected text. And if everything goes well, then we should see access token here. Right, so you see this is my debug statement, the token, and we are getting the token. So the first step is working fine, which is basically to get the token. And if you remember in Postman, how we were getting it was from here we were going to the authorization and we were hitting this button, get new access token. This was giving us the access token, and that part we have done in our code as of now. So as of now, the connection between this child org and the parent org is working fine. We are able to get the access token. The next step is to get the session ID and then to make a call out to the agent, invoking the agent through the agent API. So let's see that part in the next lecture. This class I'm going to add in the resource section, so you can just refer this while writing this Apex service. Now let's move to the next part of this Apex class. So as of now, we have got the access token through this method, but who's going to call this access token method is our get session ID. Again, if I go back to the Postman, so if you see to start the session, we were passing the agent ID here, and in the authorization, we were passing the access token. So as of now, we have the access token. And now the next step is we need to invoke this endpoint, passing the access token in the header. And in the body, we need to pass this JSON, and what it will return us back is the session ID. So let's just do that once. So we got the access token, click on proceed and use the token. So now this token is updated. And then here in the start session, now we can invoke this endpoint where we have to pass the agent ID. And this is the payload that we need to pass in the body, and in the authorization, we are passing the access token. Once we hit this, it will give us the session ID. Right, so here is the session ID. And now if you remember, when we hit this next API, which is the final API, in this one we have to pass the session ID as well as the token. So as of now, the Apex method that we have written is giving us back the access token, and now we are going to write this method which is going to give us the session ID. But to hit this endpoint, the send message synchronous or streaming, we need both. We need the access token and we need the session ID. So what I'm trying to say is that now the method that we are going to write, it should not just return session ID, but it should also return the access token. Obviously the access token it is going to get from the previous method that we wrote, and put together it should frame a wrapper which will have the session ID and the token, because once we hit this endpoint, in this one we have to pass the access token as well as the session ID. So now let's just write a method which will hit this endpoint and get the session ID from here. So point to be remember is this is the endpoint that we are going to hit, and in this one the body will be this JSON payload. And I can comment this code for now. Okay, so here let's write another method. Now, what is this method going to return? Is it only going to return us the session ID? Like this one is returning us the access token. This new method, what is it going to return? The session ID? No, we need the access token as well as session ID. The access token is returned by this get token method. I'm not going to call this method again and again because it will make call out again and again. We already got the access token, which our session ID method will invoke right now. And since the method will have access to access token as well as session ID, so it can return a wrapper containing both. So I'm just going to create a wrapper here. So this is a session info wrapper, and in this one I'm going to store access token as well as session ID, and you see that I'm marking it as Aura enabled. So which means that this information will be sent back to the LWC component. So the goal here is that the method that we are about to write right now will be run by the connected callback. The moment our LWC component loads, that is where we are going to invoke the session method that will give us the access token as well as session ID, and we will keep it handy in the LWC component. And anytime we have to invoke the agent, we will always pass the both access token and the session ID to that method. So now next step is we need to write this method to get the session ID. First of all, again in the Postman we saw that we need to prepare this JSON. Again in this one there are some parameters which are actually optional, like time zone and all. If you want to skip, you can skip that, but overall this is the payload that we have to prepare. In this one there are two important things. One is the external session key, which is basically a random ID that you have to generate, and it should be always random in every time you want to generate a session ID, and you have to pass the org domain as well. So first let's write a method which is going to prepare this JSON for us. So I'm going to copy this method from my existing class and I'm going to paste it here. So let's just see what is this method doing. So the name of the method is getJSONBody. It is generating a session key. Again, it is just using crypto.getRandomLong. So it will give us a random value that we are going to use as a session key. So this is where we are preparing that JSON body, and it is actually copy paste of this payload. I need the external session key, which is a random ID. So here it is, external session key, which is the session key here, which is actually a random code. And then after that we need the instance config. Within that we need the endpoint. So instance config, in that I have endpoint, which is my org domain. And how is this org domain coming? This is coming from the metadata. So in the metadata we have stored this org domain, right? So that is what it is coming. And then all these parameter I'm storing it. If you don't want, you can remove these values from here, but overall this is the JSON body that we need to send while making a call out to the session endpoint. So this is the method that I'm going to utilize. So now I have my response, which I need to send back to whoever is going to call this session endpoint. And in this session endpoint and in that session endpoint, this is the method that it will execute to get the JSON body that it needs to send. So now let's write the method here. Again, it is written, so I'm just copy pasting here. And it is aura enabled. So you see this get token method is not aura enabled. LWC is not going to call this one. Rather, it is going to call this get session info method from the connected callback. That is why I marked it as aura enabled. And here the first thing that we are doing is getting the token, because you know that to get the session we need to pass the token. So this is where we are going to call this token. It will give us the token. So this token is going to be stored here, and then we are going to make a call out to the API endpoint. Here we were making call out to the token endpoint, and now we are making call out to the API endpoint. And if you remember in the metadata, we have this API endpoint as this till v1. So after v1 we have to concatenate which endpoint that we want to invoke. So in the Postman we can see that for session after v1 we have to add agents, and we have to pass the agent ID /sessions. So let's go back to the VS Code. So here that is what I'm doing, API endpoint, which will be till v1. After that we are saying that /agents, and this is the agent ID I'm passing. So for whichever agent I want to start the session, that agent ID I'm passing here. Again, this agent ID is coming from the metadata. We have stored the agent ID in the agent ID in the metadata. So that is what I'm getting here. And this is my final endpoint that I need to invoke. And this is my endpoint. The method will be post. So now to make call out to this endpoint, we need to pass the access token. And that access token we have already obtained through this method. So this method was giving us the access token that is here. And that is what we are passing here. Content type is applicant JSON. And in the body, we have to pass that JSON, which we saw in the Postman. So this is the JSON that we need to pass in the body. So I'm calling it here get JSON body. It will give us this JSON structure which we need to pass. And finally we are making a call out here. This will give us a response body. And if I show you what exactly we are going to get back, we are going to get back this entire payload. This entire payload is what I'm going to get back. So I'm interested in the session ID. If you want to show this message, you can actually work with the messages payload here, but I need this session ID. This is what I'm going to send back, and I'm going to use it again and again. So that is what we are doing that. So once we get back the response, if the response is not null, we are going to parse it. And from that, I'm going to extract the session ID. And then I'm preparing this wrapper, session info wrapper, which we declared here. In the session info wrapper, we are going to send the access token and the session ID. So we are storing the access token and the session ID, and this is what we are returning back. So I hope you understood the flow. This is the method that will be invoked by the LWC component or whatever you are building, whatever is your UI. This is the backend that you have to invoke. You need to invoke this get session info, because this is the one that will make a call out to get the token, and then it will get the session ID and it will send it back to the caller. So again, if it is a LWC component, that is why I need it to be aura enabled. Right, and at this point we will have the session information. So let's just test it out here. So I can say that the session will be Okay, so headless agent service dot get session info, I'm going to call this method, and but before that I need to deploy this. So we made some changes, we have to deploy that to the org, right? So there is no error here, and let's just invoke it. What will happen is if it gives us the session information back, then we should get this wrapper with access token and the session ID. So let's just see that. Right, so here we see that the session info is session info. So we have the access token and we have the session ID. Access token is this big one till this point, and then we have the session ID. So with this method we are getting the access token and we are getting the session ID, and we are ready to make call out to the final endpoint, which could be your synchronous endpoint or the streaming endpoint, because in the synchronous one or streaming one we were passing the access token and we were passing the session ID, and in the body we just need to send our text message. And now let's move to the next endpoint, which is this send message endpoint. So either you can use the synchronous one or the streaming API one. Both authorization is same. So in authorization, we have to pass the access token. In the body also, we have the same body here in the synchronous one. And in the streaming also, we have to pass the same body. Only difference is in the endpoint we have messages / stream, and in this one it is just messages. So for our use case we are going to work with this one. Here the important point is that in the authorization we have to pass the access token, and in the URL we have to pass the session ID, and both of this information is given by the get session info method that we have just wrote. So the only thing that we have to do in this new method is we have to prepare this JSON, which is actually very simple one. We just need a sequence ID, again some random timestamp that you can send here, the type, what is the message type that you want to send, and the actual message or the prompt that you want to send to this particular agent. So this session is currently having with an agent. So to that agent, what is the prompt that you want to send? So this is the JSON body that we have to prepare. Again, the endpoint is same, like till v1 it is same. After that we have to invoke the sessions endpoint. Here we were invoking the agents endpoint. In this case we have to invoke the sessions endpoint, pass the session ID / messages, and in the body pass this payload. So let's just write this new method. So here after this we can write this new method, and I'll explain you what we are doing here. So here you see that this is the invoke agent method, where we are going to pass the access token, the session ID, and the final message. So this access token and the session ID is actually stored through this method. When we invoke this method, it would give us the access token as well as the session ID, that we are going to store it into the LWC's variable, and that is where we will pass here the access token and the session ID and the user message as well. So the flow of execution will be like this. In the LWC component, we will invoke this method in the connected callback, and it will return back the access token and session ID, which LWC component will store. And every time when we have to invoke the agent, we will call this method, pass the same access token and the same session ID and the message here. So this message is something that we will prepare in the LWC itself. So let's say when the user selects one of the book, then we will prepare a dynamic message saying that recommend similar books with this title, this genre, and this language. So that message is something we will prepare in the LWC and we will pass here. And then we are going to hit this endpoint where we are going to invoke our agent. So the same API endpoint, which is ending with v1, and we know that to access the messages we need to call the sessions / the session ID which was generated for that agent, and messages. Here we are going to make a post call out, and then the token is the same token we are passing here as well. And as we saw in the Postman, this is the JSON body that we have to pass. We need to pass the sequence ID, which is the timestamp. So we are just getting the timestamp here, and the text message, whatever is the prompt that user has given, the same prompt we are sending here and making a call out. So what it will return us back is, let's see Postman here, and if we hit here, I hope the token is still valid. Okay, token is expired. So again, same thing you have to see in your LWC as well, in your master, or what is the timeout of your token. In case the token expires, then you should generate a new token and get a new access token. Start a session and then send this message endpoint. So this is the payload that it will send us back. Again, this is a synchronous one, so it will wait for the message to completely generate. And in this one, we have this messages. Within that, we have the actual message that or the response that our agent has generated. So this is what we need to take out. So here, once we make this call out, it is going to give us back the response body. If the response body is not null and it is not empty, okay, you can also check if the status is 200 or not, because it may time out. Again, this is not a headless agent is not a very good use case for Apex because you have a timeout of 10 seconds here. But in case of your Node.js application where nothing like that happens, there you can increase your timeout to 20 second or 30 second, because this API can take more time. The synchronous one can take more time to respond. The streaming one will not take this much time, but the synchronous one can take that much time. So you have to handle that error scenarios as well. So the response status should be 200. In that case, we are deserializing this messages, and from there we are getting this messages 0th index, which is basically this messages 0th index. In that we have the message parameter. That is what we are getting, and that is what our final message is, and that is what we will return back to the calling application. So the calling application is going to call this invoke agent with the access token, session ID, and the message, and it will make a call out. It will get the messages. In that, it will find the message parameter and it will send it back to the UI. So this is our final class, and let me just save it and let's try to deploy it. Okay, it will give error because I have a debug statement here. Right, so it got deployed. So this is our final class, and it has 3 methods. The first one is get token, which is to get the access token. Once we have the access token, we can start a new session with this agent, and that is where we will have the access token and the session ID. This is what we will return back to the LWC component, and it will store it in the local JS variables. And then finally, whenever we have to make call out to the agent, let's say after a few minutes someone clicks on some book as a favorite, that is where we will invoke this message. That is where we will invoke this method, passing the access token, session ID, and the message, and it will make a call out passing this JSON body, basically the prompt that we have passed from the LWC, and it will get back the response from the agent. Then you can decide what do you want to do with that final message. Do you want to show it as a toast, as a notification, or maybe a new section that you want to render on the UI? So all of that is your UI design, however you want it to be. So I hope you understood what is this class doing. It is basically utilizing this agent API. So whatever the steps that we did in the Postman, we are doing all of that in this Apex class as well. And now testing it from the anonymous block is little complex, because you see, if I have to invoke this invoke agent, I first need the access token, which means that I need to make a call out here to this one, which will give me the access token and the session ID. So I basically need to make 3 call outs if I want to test it from the anonymous block. To finally invoke this agent, I need the access token and session ID. So that will be like 3 call outs in the same transaction, and definitely we will get the timeout exception here. So maybe let's just test it out in the LWC, because in the LWC, this will be divided in 2 different transactions. We will first call this get session info, which is going to make the get token and the session call out. So this will happen in one transaction in the connected callback, and then later we will directly invoke this invoke agent. So that's 2 different transactions. So both will have their own limits, and we won't see the read timeout error when we test it with the LWC component. So let's just see that in the next lecture. Right, so now our backend is ready. We have this headless agent service where we have this method called invoke agent. Using this, we can invoke the agent which is currently residing in the other Salesforce org, the master Salesforce org. And although maybe this Salesforce org does not have Agentforce enabled, data cloud enabled, but with the help of this agent API, it can invoke the agents which are residing on the parent or like master Salesforce org, and can use the generative AI for providing better recommendation. Now in this lecture, let's see that how we can utilize this Apex class to show the recommendation on the library application. But before that, in this org, let's see what we have. So in this org, we have this books object. In this one, we have like 30 to 40 books added right now. 40 books are currently added here. And to display these books in a very nice way, we have this LWC component here. this entirely a single LWC component where we are showing all of these books in a tile manner, the name of the book, the genre and the language, the price, and we also have this favorite icon here. So all of that is coming up here, and also we have this search facility. So very traditional LWC component where you display the records and allow users to search for it. So here if I search for any books, that also I can do that. So that's our LWC component. And I have loaded some books record, and let's go back to our IDE. So in this IDE, I have loaded some books record in the org. So this is my books. So this is my CSV data that I have loaded. Again, for this also I utilize my cursor. So here, if you see, I ask cursor to access this books object. So this books object is here in the objects tab. All the fields are available here, and whatever the fields are available, that is here. And I instructed cursor that help me with the sample data creation for the book C object in my sandbox org, generate a CSV file with around 30 to 40 sample records. So you see, I did not prepare this CSV, but rather I utilized cursor to generate this CSV file, and I just did a data load. Maybe I'll add this CSV file also in the resource section, so you can do a data load. And after that, to display these books, we have this LWC component. So this is our LWC component. Let's just see this. Again, I utilize cursor to generate this LWC component. 90% of the code was written by cursor, and I just made few changes here. So here I asked it to generate this LWC component, and that is what it is using right now. So here, this is a very simple LWC component. So we have this book library here, and we have the ability to search for any books here, and a button to search for the books if you want to. And then finally, all the books that comes from the Apex class. So we have this book controller here. In this one, we have two methods: get all the books, so basically querying all the books and displaying it in the card manner. So for that, I'm utilizing this method. And when users search for any book, for that we are utilizing this method. So these are the two methods of this class that this LWC component is using. So once we have all the books, that books we are displaying in this card manner. And then this is the recommendation section. So you see, whenever someone clicks on the favorite icon, so this is what will show up, that pop-up or a notification showing the recommendation coming from the master org. So for that, we have this template here. The moment I make show recommendation as true, this will start showing up on the UI. And now let's go to the JS side. So in the JS, we have got both the methods from this book controller, get books and get all books. And get all books is a wired method. So once the component loads, it get all the books, and that's how the component is rendering. But our focus is on these two methods here, which is the one that we created in our last lecture, the get session info and the invoke agent. So as we discussed, this get session info is something that I'm invoking in the connected callback. So in the connected callback itself, we are going to call this get session info. And if you remember, what we are doing in this get session info is we are going to first get the token in the get. So this is, we are going to do only one time in the connected callback. That's why I'm calling it in the connected callback. In the connected callback, we invoke this, which is going to get the token, and using this token, it will invoke the agent API, which will generate a session ID, and it will return back the session info containing access token and the session ID. So this is what we are calling here, and then we are storing that session info in this JS variable. So we have declared it here. Session info is object. So in this one, now we will have our access token and session ID. So whenever we want to make a call out to the other org's agent, we will utilize this session info, because this will have the session ID and the access token. So that's it. In the connected callback, we are just invoking this Apex method that we created in our previous lecture, and it will give me the access token and the session ID. Again, you can have a better implementation for this. You can store the session ID or maybe the access token in the platform cache. You can store it somewhere else in some object instead of storing it directly in the JS. But for this example, I think this is fine. And then we have this handle search change, which is just searching for the books and showing all that. So all of that is here. And then we have this important method, handle favorite toggle. But before that, let's just see that if our session info is working or not, because I have logged it here. So the moment I refresh this component, connected callback will run, and it will invoke this method, and we should see the session info, which is the session ID and the access token. So let's just see that. So here I can open the log panel, and let's move it to this side. Okay, so the moment I refresh, the connected callback will run. Right. And you see that in the connected callback, we got the session info initiated. So we got that session info wrapper. This is having the access token and it would have started a new session. So that is here. So this is the session ID. So now when we have to make a call out to the agent, we are going to pass this session ID as well as this access token. Again, not a very safe implementation. Just storing the access token in JS is not a very good implementation, but that is fine for this example. Okay, so now let's go back to our JS, and here I was talking about this method handle favorite toggle. So the moment someone clicks on this star icon is when this method will be invoked. And first of all, we just show a toast message saying that this book is added in your favorites. Again, we are not doing anything. Ideally, we should create a record saying that all of my favorite books. But for this example, I'm just showing a toast message that this book is added to your favorites. And then we are invoking this method called get recommendation. And in this get recommendation, we are just checking that if the session info is not null, which means that in the connected callback, if we have the session info or not, then we are preparing this message, which is the prompt that we are going to send to our agent. So whichever the book that user has currently clicked on favorite, from that book, we are generating this message dynamically. Find recommended books similar to the book name that the user has currently clicked on, language, the book's language, and the genre. So this is the prompt that we are going to send to our agent. And then we are invoking this method. We have seen this method in our last lecture, invoke agent. So this is basically this one. So it requires the access token, session ID, and the message. So that's exactly we are passing here. We are passing the access token from the session info. We are passing the session ID from the session info, and we are passing the message which we just prepared here. So now we know that what it will do is it will invoke the agent API, passing this message, and after some time it will get back the recommendation. Once it has the recommendation, we are storing that recommendation here. It could be a rich text or a simple text message coming from the agent, and we are making show recommendation as true. Because of that, what will happen is here on the HTML, this show recommendation will become true, and then we will show this, this notification will come from the right side, and it will show all the recommendation here in the lightning formatted rich text show recommendation. And then if you want to go ahead and improve it, then you can add more buttons here that whatever the books that is coming from, if the user wants to request for those buttons, you can have a button here saying that request for these books, and then the librarian can raise a change request and the books can come to this library. So that's how we are utilizing this agent API in this LWC component, and let's just see the demo of it. So this entire LWC component is like showing everything. It is showing those books, it is allowing for the search, and it also has this recommendation section. So let's just see that here. So here we can search for books, and then when we go ahead and search for and we go ahead and make some book as a favorite. So this is where that action will be invoked for the Gone Girl. So the book name Gone Girl, genre is thriller, and language is English is what the message will be prepared, and it will be sent to the agent. The agent will respond back with this text. So this is the response that it is sending, and that's what we are showing as a book recommendation. So in this case, although we are invoking the agent, the users are not directly invoking these agents, but rather from the backend we are doing that. So similar to that, if you have more agents in your master org, you can invoke all of them. Like maybe at the checkout you want to invoke some agent to do some calculation, you can do that, and the users are not directly invoking these agents. Again, this LWC component is actually a very big one. So I'll add this LWC component in the resource section. You can go through it to understand what we are doing in this one. And this book object as well as this sample data, everything I'll upload in the resource section. So you can just deploy this into your org and create some sample book record, and set up your master org with the data cloud and the agent, and then test this agent API if you are able to see it working. But I hope you understood the concept. The understanding of the concept is important. Why would you build these agents? These are nothing but service agent only, right? So in the master org, they can be deployed to service cloud and people can use them as a conversation agent. But for this particular org, this is acting as a headless agent, which it is invoking for different activities.